Hello guys, you're welcome to my YouTube channel Mathematics Made Easy. So in today's video, we'll be solving this beautiful sum. We have sum of 1 over 2n factorial, then n is from 0 to infinity. So guys, how do we solve this beautiful sum? It's so simple. The result is so nice. The result is so nice. Alright guys, so if you are new in this channel, please don't forget to subscribe to my channel, like my videos, comment, share, and also click the notification button so that anytime I upload video, you'll be the first to watch. All right. So now, in this beautiful sum, I would like to use Laplace transform to solve this sum. Now let's start. So I can say that let f of t be equal to the sum of n from 0 to infinity, then of t raised to the power of 2n over 2n factorial. And also I can say that let f of s be equal to the Laplace transform of f of t. So if f of s is equal to Laplace transform of f of t, then f of t will be equal to the inverse Laplace of f of s. Okay, now let's find the Laplace transform of f of t. So we can now say that f of s is equal to sum of n from 0 to infinity of the Laplace transform of t raised to the power of 2n then over 2n factorial. So what we have to do now is to know the Laplace transform of t raised to the power of 2n. So how do we know it? So let me quickly recall this. Recall that the Laplace transform of t raised to the power of n is equal to n factorial over s raised to the power of n plus 1. So in this case, n will be equal to 2n. So we are going to substitute n to be 2n. Then if we do that, so the Laplace transform of t raised to the power of 2n will be equal to 2n factorial then over s raised to the power of 2n plus 1. So we are going to have f of s is equal to, then since we already know that Laplace transform of t raised to the power of 2n is this, so we're going to have sum of n from 0 to infinity then of 2n factorial over s raised to the power of 2n plus 1 multiplied by 2n factorial. And we can see that 2n factorial, we cancel out 2n factorial. So what we have now is f of s is equal to sum of n from 0 to infinity of 1 over s raised to the power of 2n plus 1. So we can see that these are geometric series right here, geometric sum. So how do we solve this? Now, it's not something that is hard. So let's quickly solve this. All right, let's move on, guys. So what we have now is f of s is equal to sum of n from 0 to infinity of 1 over s raised to the power of 2n plus 1. So I can start substituting the value of n from 0. You know, n is starting from 0 to infinity. Then if we do that, we are going to have 1 over, so when n is 0, that will be 2 times 0, which is 0 plus 1. We're going to have 1 over s raised to the power of 1 plus, when n is 1, that will be 2 times 1. 2 times 1 will give us 2 plus 1, that is 3. So we have 1 over s raised to the power of 3. When n is 2, 2 times 2 is 4 plus 1. So that will be 5. So we are going to have 1 over s raised to the power of 5 plus, when n is 3, 2 times 3 is 6 plus 1. We are going to have 1 over s raised to the power of 7 and so on and so forth like that till infinity. Okay, so the next thing I'm going to do is to find the common ratio. So if I should find the common ratio, R will be equal to, Tn over Tn minus 1. It means it can start from the second term over first term, third term over second term, fourth term over third term, and so on and so forth like that. So we have Tn over Tn minus 1. So the common ratio, that will be 1 over s raised to the power of 3 divided by 1 over s, so which will be equal to 1 over s raised to the power of 3 multiplied by s, which is equal to 1 over s raised to the power of 2. And then if you also do this, 1 over s raised to the power of 5 over 1 over s raised to the power of 3, you are still going to get 1 over s raised to the power of 2. That's a common ratio. So sum of geometric progression or geometric series to infinity, so this will be equal to a over 1 minus r, where a is the first term and r is the common ratio. And here r is less than 1. Okay, so r is less than 1. So we are going to have s infinity is equal to the first term, which is 1 over s raised to the power of 1, So 1 over s. So divided by 1 minus the common ratio, which is 1 over s squared. So we are going to have s infinity is equal to 1 over s divided by s raised to the power of 2 minus 1 over s raised to the power of 2. So s infinity will be equal to 1 over s multiplied by s raised to the power of 2 over s raised to the power of 2 minus 1. So s will cancel 1 s here. So we are going to have s over s raised to the power of 2 minus 1. So that is this. That this f of s is equal to s over s raised to the power of 2 minus 1. All right, guys, we are not done yet. So what we have to do is to find f of t. Then how do we find f of t? For us to find f of t, we have to take the inverse Laplace of both sides. So taking the inverse Laplace of both sides, we have inverse Laplace of f of s to be equal to inverse Laplace of s over s raised to the power of 2 minus 1. And don't forget, I said inverse Laplace of f of s will be f of t. So f of t will be equal to inverse Laplace of s over s raised to the power of 2 minus 1. So how do we find the inverse Laplace of s raised to the power of 2 minus 1? So that's the next thing we want to do. So find the inverse Laplace. I want to find inverse Laplace of s over s raised to the power of 2 minus 1. So the first thing is to split this into partial fraction. We want to split s over s raised to the power of 2 minus 1 into partial fraction. That is, s over s raised to the power of 2 minus 1 is also equal to s over s minus 1 multiplied by s plus 1. That is square difference of 2 square. We have a square minus b square. So this will be equal to a minus b multiplied by a plus b. So that is what happened here. So the difference of 2 square. So we have s over s minus 1 multiplied by s plus 1. Okay. So now let's move on. So if we want to split this into partial fraction, we can say that, let me partition the board. So we can say that s over s minus 1 multiplied by s plus 1 is equal to a over s minus 1 plus b over s plus 1. So what we are going to do next is to multiply both sides by s minus 1, s plus 1. So we do that, s will be equal to a into bracket s plus 1 plus b into bracket s minus 1. Now let's do substitution method. So let's set s minus 1 to be 0. Then if you do that, s will be equal to 1. So you put s to be 1 here. So you are going to have 1 is equal to a into bracket 1 plus 1 plus b into bracket 1 minus 1. So we are going to have 1 is equal to 2a. Then you divide both by 2. So we have a is equal to 1 over 2. Another one, you substitute s plus 1 to be 0. You set s plus 1 to be 0. So s plus 1 equals 0. So you are going to have s is equal to negative 1. So substitute s to be negative 1 in this equation. So we are going to have negative 1 is equal to a into bracket negative 1 plus 1, then plus b into bracket negative 1 minus 1. So that will be negative 1 is equal to, now negative 1 plus 1 will give us 0. Multiplied by a, that will be 0. And negative 1 minus negative 1 minus 1 is going to give us negative 2. We have negative 2b. Then we divide both sides by negative 2 over negative 2. Then we have b is equal to 1 over 2. So b is 1 over 2 and a is 1 over 2. So we can now say that s over s minus 1 multiplied by s plus 1 is equal to 1 over 2 into bracket s minus 1 plus 1 over 2 into bracket s plus 1. This is now beautiful. This is beautiful. Okay, guys, let me clean this part. So we've splitted that into partial fractions, so it should be easy for us to find the inverse Laplace now. Now, so let's find the inverse Laplace. So don't forget, f of t will now be equal to the inverse Laplace of this splitted fraction. Let me write it here first. So f of t will be equal to the inverse Laplace of 1 over 2 into bracket s minus 1 plus 1 over 2 into bracket s plus 1. Okay, so f of t will be equal to the inverse Laplace of 1 over 2 into bracket s minus 1, then plus the inverse Laplace of 1 over 2 into bracket s plus 1. So you can bring out this 1 over 2. So you are going to have 1 over 2 multiplied by inverse Laplace of 1 over s minus 1 plus 1 over 2 multiplied by the inverse Laplace of 1 over s plus 1. Now, recall that, if you take the Laplace transform of e raised to the power of a t, this is equal to 1 over s minus a. Now, relate this to this. If you relate it to this, that shows that the value of a here is 1. Okay, so the inverse Laplace transform of 1 over s minus 1 should be equal to what? E raised to the power of t. That is, you are going to substitute a to be 1. You are going to have e raised to the power of t. That's the inverse Laplace of 1 over s minus 1. Now, what about this one? So let me clean this part to solve for the inverse Laplace of the second function there. Okay, so now, what about this one here? So, we can write 1 over s plus 1 as 1 over s minus 1 because minus multiplied by minus will give us plus, okay? Therefore, we can see that the value of a here will be what? Negative 1. So the value of a is negative 1. So just substitute a to be negative 1 here. So we are going to have the inverse Laplace of 1 over s plus 1 is equal to e raised to the power of negative t. All right, so since we have the inverse Laplace of this and this, so let's bring the two answers together. So we are going to have f of t is equal to 1 over 2 e raised to the power of t plus 1 over 2 e raised to the power of negative t. So that is f of t. But our main goal is to know the value of this sum. Now, s will be equal to when t is equal to 1, because if you substitute 1 here, we are going to have 1. So that will be sum of 1 over 2n factorial of n from 0 to infinity. So at t equals 1, we are going to have our answer. So at t is equal to 1, so we are going to have f of 1 is equal to s, which is equal to 1 over 2e raised to the power of 1 plus 1 over 2e raised to the power of negative 1. So this is equal to 1 over 2e plus 1 over 2e raised to the power of negative 1. So that is the answer to that beautiful sum. Okay, guys, if you like this kind of video, please don't forget to subscribe again, like my videos, share, comments, and click the notification button. See you next time. Thanks for watching.